Welcome, viewers. We haven't recorded in quite a while. I would like to let you guys know that I got a new tripod, and Jonathan and Gracie set it up for me. I have tech support, so we will see how this video goes. All right, welcome America. Welcome Justin Bieber. Jamie will be attending your function. Coming up here shortly. So for some reason they didn't give me a ticket. So if you could hook me up, that'd be great. Okay. So,
well, now he's going to. Don't even worry about it.
I mean, I'm sure he's watching. So he'll get me a ticket somehow. All right, we're going to start with number 3, then we're going to go to 6. So we're going to solve this equation just like we would. We're going to from algebra 1. So we're going to subtract 1 from both sides. If you do 1/2 minus 1, you're going to get a negative 1/2. And that negative is still in front of cosine. So then that is equal to cosine of x equals 1/2. Where does cosine equal 1/2? We've got tall angles in more than one quadrant. Because x is positive, cosine is positive in the first quadrant and also the fourth quadrant. So the cosine of x is 1/2 in quadrant 1 and also quadrant 4. So these are the tall angles. So they are going to have denominators of 3. So that is going to be x equals pi over 3. And I'm going to leave some space because you know what we're about to do. And x equals 5 pi over 3. Now we're asked to find the general solution for each of these. And we have an infinite number of solutions at this location. Because if I add 2 pi, 1, 2, 3, 4, an infinite number of times, I'm going to get another solution. So the way we represent that is we say the first one, which is pi over 3, and then plus 2 pi an infinite number of times. So it's plus 2 pi k. Same for 5 pi over 3. Plus 2 pi k. So here's solution number 1, and here's solution number 2. How am I doing?
Great.
Love to hear it.
I think the cinematography is really added.
The cinematography is fire. Not gonna lie. All right, we are going to move to number 6. So if I add 8 to both sides and then divide by 5, I've got 5 cosecant of x equals 10, and then I divide by 5, I get cosecant of x is 2. Are you with me?
Yes.
Okay. So if the cosecant of x is 2, and that's the reciprocal to sine, then the sine of x equals 1/2. And those are the short angles. And sine is the y distance. So that's in quadrant 1 and also quadrant 2. So we have x equals, so that's at pi over 6 plus 2 pi k. And also x equals 5 pi over 6 plus 2 pi k. When do you guys think I'm getting my smart board? Because the spring is coming soon now.
Like
This summer, probably.
They said spring.
That means
Spring of
summer.
what
That could be March.
That
Didn't they
means-
also
You don't
say
know?
October and the beginning
That
of the
means
school
summer.
year?
True.
Yeah, I mean, is their word reliable at this point?
Maybe my smart board is important to them.
Oh.
You're right. They
Probably not.
we watch your channel.
It's nice to be
You
optimistic.
don't know. All right, we're moving on to something a little bit more difficult. Is anyone still writing this down or have questions about these solutions?
Does it get any harder than this?
Yes, it does. Thank you for asking.
I hate
You're
that
welcome.
question. I always want to ask it, but I'm like, oh.
I was like, oh, I'm getting it.
It's good. All right, we are going to go now to number 4. This is messy, so I'm just gonna erase all this stuff, just so we can have a little. I'm gonna erase this too, because it's just messy. Less to look at. Number 4. Okay, notice we've got a funky angle. We've got the sine of 3 theta equals -1. Whenever we have a weird angle like that and we want to solve, what we can do is we can just take that angle and set it equal to, sometimes people use x. I don't like x because then I forget to set it back at the end. I like to use u, the letter u. So, and it's pretty common. We're going to say let u equal 3 theta. And then we're going to rewrite the equation with the u. So the sine of u equals -1. Well, where is that? That's at 3 pi over 2. So u equals 3 pi over 2. That is messy. Let me try that again. 3 pi over 2 plus 2 pi k. We're almost done. So if I had used an x instead of u, I would have x equals this, and then when I use an x, sometimes I forget that I have to substitute back into 3 theta. But if I use a u, that reminds me after I write this general solution that I'm not finished yet. Now I have to substitute the 3 theta back in for the u. That is not theta, it's q. We are almost finished. We just have to isolate the theta. Currently it's being multiplied by a 3. So we're going to divide the entire equation through by 3, and then we're done. So theta equals pi over 2 plus 2/3 pi k. How do you feel about that?
Makes a lot more sense, so it's fine.
And you have to divide each of the terms. Just like from algebra 1, if you're dividing through by 3, you have to divide this term by 3, this term by 3, and this term by 3. Is everyone okay with dividing 3 pi over 2 by 3 and getting to pi over 2?
Yeah.
And you could have written this as 2 pi k over 3, but I just wrote it 2/3 pi k. It's the same thing. Good? It's called substitution. Use substitution. It's kind of fun. I'm not going to lie.
I just.
Did you just say it's kind of fun? It's just like how Kayla likes graphing.
You like graphing?
I enjoy graphing.
Oh
I
my
think
god,
that-
you guys. Just not old arcade.
Yeah?
Can you explain the beginning part again?
The beginning part. So in each of these problems that we've done before this one, we had a very nice angle like x or theta. Here we have a 3 theta. So we set it equal to just the basic angle so we could use the unit circle and then substitute back into 3 theta to get the actual solution. And we're going to do that again here. So see how we've got this weird angle, this theta over 2? We're going to let u equal this theta over 2. Solve it like we would normally. And then at the end, substitute back in the theta over 2 for the u.
I still don't get like how like the pi over k or pi k works exactly.
So, okay, so this is 3, okay, so from here to here, that's 3 pi over 2, right? The next solution is if I add another 2 pi, I come around and I get back to the same location.
Yeah.
I can do that an infinite number of times. I can keep adding 2 pi and get another solution.
Yeah.
And then add 2 pi again, another solution. And so the way we represent that is we say 3 pi over 2 plus 2 pi an infinite number of times. And we just use k to represent that.
Oh, okay.
It's just like when we were doing the asymptotes for the tangent. We had an infinite number of them. We just did like pi k.
Yeah.
Because k is 1, 2, 3, 4, 5. And so we're adding 2 pi 1 time, and then 2 times, and then 3 times, and then 4 times. All right, so number 5. Let theta over 2. I lied. Let u equal theta over 2. This one's pretty basic because now this just says the tangent of u equals root 3. And hopefully, I mean, it's been a while, but hopefully we have that memorized, that those are tall angles. And where's the tangent positive? In quadrant 1 and also, where am I? Quadrant 1 and also quadrant 3. Because it's positive in the first quadrant because sine and cosine are both positive. And it's positive in the third quadrant because sine and cosine are both negative. So negative divided by negative is a positive, and a positive divided by positive is also a positive. All right, so where am I at? So let me write this as u equals pi over 3 plus, now, instead of writing multiple solutions here, I know that the distance from this solution to this solution and then from this solution back to the original solution is the same. So I'm not going to write each of those two solutions separately and say plus 2 pi k because that's redundant. Rather than doing that, since the distance is the same in between each of the solutions, I'm going to add pi to get to the next solution, and then pi to get to the next solution. So we're going to add pi k times. So I only have to write one solution rather than both separately. You can just write 1 pi over 3 and then add pi to get the next solution, and then pi again, and then pi, and then pi. So this is going to be pi over 3 plus pi k. I know, it's not easy. Then we are going to substitute back in theta over 2. I'm running out of room. I'm going to rewrite this up here. Am I going too fast? Okay. Last thing I need to do is multiply through this entire equation by 2. So we have theta, not theta over 2. And that's going to be 2 pi over 3. So theta equals 2 pi over 3 plus 2 pi k. Boom. I think that's enough for our video. Anyone, Jamie, do you want to do a plug for Mr. Heritage?
You know what? Yeah, I will actually.
Yeah, I mean, you're comfortable in front of the camera.
Oh, come on.
Yes, anyone. Naomi, do you want to do a plug for SCA?
Yes, SCA. Come on, Naomi.
Oh, I wish I could see myself. They need to go in first. I'm getting a little camera shy.
I would like to present to you Heritage SCA. America.
3 of them.
Justin Bieber.
3. We are the S, the C, and the A. I'm the C, in no matter which way you look. One of us is the S or the A. So, Mr. Heritage is such a fun competition. Come next Friday, February 11th, then what is happening on the 12th?
And on the 12th, we're all going to go to Ion and ice skate from 7:30 to 9:30.
First come, first serve.
Oh my gosh, I can't believe
Be
I'm gonna miss
there
this.
or be lame.
Yes.
Love it.
That's all I have to say.
All right.
I'll see you there.
Thanks, America.
Thanks, America and Justin Bieber.